Hello everyone, this is Ketish here. In this video, I'm going to go through question number 6 from the AQA 2021 Combined Science or the Trilogy Physics Paper 1 Higher Tier. Now this question is on the topic of energy. It links to specific heat capacity as well and the particle model in terms of pressure as well. So there's two topics that is actually linking. Question number 6, an air source heat pump transfers energy from the air outside the building to increase the temperature of the air inside the building. So air outside the building and the air inside the building, you have a compressor and a decompressor, and the coolant is actually running through the pipes. The compressor is connected to the mains electricity supply. The pipe in the heat pump contains a substance called coolant. In the evaporator, which is on the outside, energy is transferred from the air outside the building to the liquid coolant. So energy is transferred from the air. So energy is actually going in from the air outside the building to the liquid coolant. The temperature of the coolant increases and it evaporates. So energy is going in. So the temperature increases. So it evaporates. So the darkened part is actually a liquid part and the top bed is actually the gas bed, right? So as it evaporates, it gets hot, and when it goes through, heat is actually transferred. So the heat actually, or the energy is transferred to the inside of the building. So you're trying to heat up the building. The temperature of the coolant increases and it evaporates. Explain what happens to the internal energy of the coolant as its temperature increases. Now, internal energy is dependent on the kinetic energy of the molecules in the coolant, which means how fast they are moving. Also, it refers to the energy contained within the bonds in the coolant itself. So, explain what happens to the internal energy of the coolant as its temperature increases. Now, if the temperature increases, kinetic energy should increase. That means the internal energy will also increase. So for 2 marks, the kinetic energy and the potential energy of the particles increases. So the energy contained in the bonds is referred to as the potential energy. So the internal energy increases because it is the sum, because you're trying to explain here. So you have to say, because it is the sum of the kinetic and potential energy of the particles. So 1 mark for that bullet point and 1 mark for that. Question 6.2. What name is given to the energy needed to change the state of a liquid coolant? You're trying to evaporate it, which means the name given to the energy needed is the latent heat of vaporization. You're trying to change it from a liquid to a gas. What happens to the mass of the coolant as it evaporates and becomes a vapor? Now, when it evaporates and becomes a vapor, it's a physical change. So the mass is not going to be affected. So the mass stays the same. The compressor increases the density and temperature of the coolant vapor inside the pipe. Explain why the pressure in the pipe increases. Now, how are these actually linked? They're asking you to explain what happens to the pressure. Well, the compressor increases the density. Density is increased by the mass, which is the number of particles. Now, the compressor is pushing the air together, which means there's more particles of air or coolant, the vapor of the coolant in a small space. Hence the density is increased, which means you're increasing the number of particles. And if you increase the temperature, that means you're increasing the kinetic energy, right? So density, increase in density is referring to the number of particles, and temperature means increasing the kinetic energy. Now explain why the pressure in the pipe increases. Now pressure depends on the force divided by the surface area. Now the force is where it's going to, if you increase the force, we are going to increase the pressure. So how does the force increase? Well, if you increase the kinetic energy, then you're actually increasing the force with which the particles will collide. If you increase the density, then the number of particles hitting the walls on the pipe also increases, because the number of collision then increases. So how do you put all of this as an answer? There will be more collisions per second, right? There will be more collisions per second since number of particles increases with density. Now, what I've written in brackets is not actually needed to get that mark. So when you say there will be more collisions per second, you get 1 mark. A greater force per collision happens. A greater force per collision also happens, hence the second mark, since kinetic energy increases with temperature. That gives you the second mark. Question 6.5 is a 6-mark question, and it's a calculation on specific heat capacity, because you can see they're asking you to calculate the specific heat capacity, which means that you need to automatically look for the equation. This equation, energy transferred equals the mass multiplied by the specific heat capacity multiplied by the temperature change, which is delta theta. So give your answer in standard form. That should generally give you 1 mark as well out of the 6. So let's have a look at the question. The condenser transfers energy from the coolant to the air in the building. When the total energy input to the heat pump is 1560 kilojoules. The temperature of the air in the building increases from 11.6 to 22.1 degrees Celsius. The efficiency of the pump is 87.5%. The mass of the air inside the building is 125 kilogram. Now, you should easily be able to get 6 marks without even before you go into this equation, because there's a lot of conversions here where you can actually get. So first of all, the energy, which is 1560 kilojoules. In order to convert it to joules, you'll multiply it by 1,000, which gives you 1,500,000. Let me write the very first. So there you go. 1,560,000 joules. That should give you 1 mark. Now the temperature change, delta theta, because you need to find the delta temperature change. That's going from 11.6 to 22.1. So let's find the difference of that. 22.1 minus 11.6. So 22.1 minus 11.6 gives me 10.5. Right? Is that right? 22.1 minus 11.6. Yeah. So 10.5 degrees Celsius. You should automatically get 2 marks just for these two, the conversion and finding the temperature difference. Now, the efficiency of the heat pump is 87.5. So the total input energy, which is that energy 1,560,000, we need to find out 87.5% of this value. So efficiency equals total input divided by, let me, so total input divided by the, oh, sorry, that's a mistake there. Let me get rid of that. So total useful energy divided by the total input energy. Now, I need to find the total input or useful energy. So I have to rearrange the equation. Efficiency is 87.5%. So I need to convert that to a decimal by dividing it by 100. So efficiency is 0.875 equals the useful energy divided by 1,560,000 joules. So the useful energy is 0.875 multiplied by 1,560,000. So 0.875 multiplied by 1,560,000. That gives me 1,365,000 joules. That gives you another mark. So we've got 3 marks so far. So finally, we can work out the specific heat capacity using this energy. So energy equals the mass multiplied by the specific heat capacity multiplied by the temperature change. So 1,365,000 equals the mass, according to the question, is 125 multiplied by the specific heat capacity multiplied by the temperature change, which was 10.5. So I'm running out of space. Let's write it down here. So specific heat capacity rearranged will be the energy 1,365,000 divided by 125 times 10.5. So answer, let's see, divided by 125 times 10.5, and that gives me an answer of 1040. Now Correct equation, substitution gives you the next 2 marks. Or the answer gives you the 5th mark. The 6th mark is to write this answer in standard form. You'd write that as 1.04 times 10 to the power 3. 1.04 times 10 to the power 3. Question 6.6. The air in the building gains 400 joules for every 100 joule of energy transferred from the mains electricity supply to the compressor. So it's actually getting more energy than you're actually putting in. An advertisement claims that the heat pump has an efficiency of 400%. Now, that can't be right. Explain why the advertisement is not correct, because nothing is, we haven't invented a machine which is even 100% efficient. It always loses energy, so it can never be 400% efficient. So the question is asking why. So how come the building is actually getting more energy than what you're actually putting in? Well, the energy should be probably coming from somewhere else. So for 3 marks, explain why this advertisement is not correct. The advertisement has ignored the energy input from the surrounding air. So the total input energy is greater than the energy supplied from the electricity. The efficiency must be less than 100. That brings us to the end of question number 6 and to the end of this video for this 2021 paper as well. Thanks for watching. I will see you in the next video. And if you want more videos of me going through, subscribe to the channel. Thank you.